Thank you very much for the invitation to come and speak with you today. So, just so we are all on the same page with what I'm talking about, I'm going to introduce some of the terms I'm going to be using in this talk. So, when I talk about cyanobacteria, that's exactly the same thing as blue-green algae. It's just a more scientific term for blue-green algae, and it also reflects the fact that blue-green algae are actually true bacteria. They've gotten lumped in with algae just because they have chlorophyll and they photosynthesize just like other types of algae and plants do. Now, when I talk about blooms of cyanobacteria or blue-green algae blooms, that's when cyanobacteria have excessive growth to nuisance levels. There isn't really an official quantification for what constitutes a bloom. There's no, say, square footage of coverage of a lake surface that says this is or is not a bloom. There's no concentration of cells in the water or concentrations of other sort of proxy measurements like different pigments. But for the most part, you can actually see cyanobacterial blooms when they're growing in the water. And then two other terms I'm going to be using, I'm going to go into more detail about this in a minute, are planktonic cyanobacteria. So planktonic cyanobacteria are those that grow floating in the water, sort of free floating in lakes. And there are also benthic cyanobacteria, and those are the cyanobacteria that actually live on the bottom of lakes and rivers. And we don't usually see them unless they kind of break free of the bottom and float to the surface, and I'll talk about that in a little bit. But something I really want to emphasize in this talk is that cyanobacteria are everywhere. There's absolutely no such thing as any lake or pond or river or stream in Wisconsin that doesn't have at least some small amount of cyanobacteria in it. You shouldn't be scared by this. It would be totally weird and wrong for none of them to be present, and for the most part, they just mind their own business and do their own cyanobacteria things. We're usually more familiar with what the appearance of the planktonic cyanobacteria that you see on the photo on the left. On the right are some benthic cyanobacteria that have floated to the surface. But the bottom center photo are cyanobacteria growing in a mud puddle. They can grow in very temporary habitats like that. I've got some growing in my rain barrel at my house. There are even some terrestrial cyanobacteria that you see in the top center photo too. So they're everywhere. For the most part, they just kind of mind their own business, and we don't need to be too concerned about them. But where we are more concerned are about the species and the types of cyanobacteria that form blooms. So I'm going to spend some time going over the different types of blooms and how to identify them, because quite often people just aren't familiar with that. You might see green water and think, oh, it's just normal green lake water, but sometimes it is a cyanobacteria bloom. So I'm going to cover that. So I mentioned these terms earlier, and these are some photos of examples of planktonic and benthic blooms. So planktonic on the left. So these are cyanobacteria that grow sort of free floating in water. They're buoyant, so they're able to float at the surface or just below the surface, as you see in this photo on the left. They can kind of get mixed in a little bit by wind and waves. When you've got calmer conditions, they might float right to the surface and form sort of surface scums or look really, really concentrated just below the surface of the water. Benthic cyanobacteria, they're a little bit different in that we usually think about cyanobacterial blooms as occurring in lakes that have poor water quality, poor clarity. Benthic cyanobacteria actually can grow in systems with really clear water with good water quality. And that's because if you step back and think about it, they're growing on the bottom of a lake and they photosynthesize, so they have to have sunlight that can reach all the way down through the water to reach them on the bottom, so they can do photosynthesis. So, for example, this image that's on the upper right side, that's very brightly blue-green colored mat. That is a pretty common sight in many lakes in northern Wisconsin, sort of mid to late summer. I've already gotten a couple of reports of these so far. And if you go back and think about, well, I guess I haven't talked about it yet. So since cyanobacteria photosynthesizing, usually these guys are on the bottom, just growing and minding their own business. But if the living's good, they're getting lots of nice sun on the bottom, they're photosynthesizing and producing oxygen, and that oxygen can bubble up within their mats, and that can lift them to the surface. So it's oxygen bubbles that lift these guys to the surface rather than sort of the natural buoyancy, the little gas bodies that planktonic cyanobacteria have. So these photos on the right are what these benthic mats look like when they float to the surface. I'll show some other examples in a little bit. So going back to those planktonic blooms, the more free-floating cyanobacteria, the spilled paint and pea soup are sort of the descriptions that are sort of the real common descriptions that people have for the appearance of these. So this photo that's on the left and in the middle, those are blooms that are occurring during really calm conditions, which allows them to float to the surface and form these surface scums that look like spilled paint on the surface of a lake. The image on the far right, that's more of those pea soup type conditions. So that water is really opaque, lots and lots of dense particles that have been mixed into that water by more waves. And you can see a little bit of waves in that image too. One other thing I want to point out is that all three of these photos, these are blooms that are actively growing and they're green. So you might wonder, where does the blue part of blue-green algae come into play? So when a lot of these planktonic blooms are actively growing, they're green because they have a lot of green chlorophyll pigment in them that they use for photosynthesis. You don't usually see the blue pigment that gives blue-green algae the name blue-green algae unless those cells die and decompose and the cell walls break open. So when that happens, chlorophyll degrades really quickly, and that's when you tend to see more of these blue pigments that are present in the cells that are normally masked by the presence of green chlorophyll. So this sort of turquoisey color is sort of a giveaway for decomposing blue-green algae bloom. So planktonic blue-green algae blooms or cyanobacteria blooms can be a lot of different colors. Those images on the left side of the screen, some species have sort of a reddish purple color. All of those images in the center of the screen and at the far right, you see sort of a gradient from different shades of sort of grungy green colors to white. And then here in the middle, you can see a little bit of that turquoise color in isolated pools along that beach. So in general, if you see really weird colors in fresh water that are from the presence of trillions of tiny little particles, you should be suspicious that that's a cyanobacteria. One other thing I want to point out that they're not always green. So at the upper right, we see a cyanobacteria bloom that's more tan or khaki colored. And I'll show you what that looks like close up. So this is a species of cyanobacteria called Gliatrichia. I think they're kind of cute, especially under the microscope. As you see on the right, they look sort of like little koosh balls or cat toys. And if you have ever seen a lot of these little tiny pinhead-sized tan balls floating in a lake, that was probably Gliatrichia. And then if you get trillions of them floating in a bloom, you can get sort of that brownish discolored water. So that's Gliatrichia. So when it comes to planktonic blooms, you do have to look closely at them just to make sure that what you're seeing actually is cyanobacteria, because we have tiny aquatic plants in Wisconsin that can really resemble planktonic blooms and are easily mistaken for them. So this photo that's on the left, you can see sort of swirly green patterns growing in this pond, and that superficially resembles a planktonic cyanobacterial bloom. But this photo on the upper right, that's a close-up of that pond water, and you can see that there's little particles in there that are actually tiny aquatic plants. The most abundant ones that sort of are these little green sort of sesame seed shaped things, they're called watermeal or wolffia. It's actually the world's smallest flowering plant. We have a couple of species that grow here in Wisconsin. There are other tiny aquatic plants called duckweeds that include the genera Lemna and Spirodella that you can see in this image on the lower right. So these larger floating plants are all those duckweeds. These really tiny, brightly leaf green colored things are a watermeal. Watermeal particles are about size of half of a sesame seed, so really tiny. So sometimes you do have to look really closely at what's growing there to make sure it actually is cyanobacteria or not. And we're moving out of pollen season, but sort of late spring to early summer, people often mistake accumulations of pollen in lakes for planktonic blooms. So it's usually conifer pollen, so from pine trees, spruce trees, and firs, and they can put out a lot of pollen. So much that you can have sort of yellow waves accumulating near shore, as you see on the left, or sort of yellowish bathtub scum and chunks floating on the surface in the middle photo. Sometimes pines and other conifers are just so prolific in spewing out pollen that you get yellow waves washing up on the shore of Lake Superior, as in the photo on the right. But the color really is one of the giveaways for this. There aren't cyanobacterial blooms that are this kind of pale yellow color. And something you can do to verify, okay, I see pale yellow stuff on a lake. Is this pollen or cyanobacterial blooms? Look for that yellow dust on land. So pollen's going to coat everything outside. So look on outside furniture, look on cars, and you'll likely see a lot of yellow dust if you see something like this in a lake too. So another thing that is often mistaken for cyanobacterial blooms is filamentous green algae. And this is where the texture really matters. It tends to be really stringy or hair-like and can sometimes form floating mats. So on the left is sort of some little tweezer pinch of filamentous green algae. You can see it's sort of long and stringy in there. And there's a mix of submerged filamentous green algae in the photo on the right, and some of those mats that have floated to the surface. So just like those benthic mats, filamentous green algae tends to start growing in early spring and cool, clear water. If it's real happy and photosynthesizing a lot, it puts out oxygen, which can accumulate in bubbles within the masses of filaments, and that can lift this stuff to the surface of a lake. Now, at the surface, it gets really stressed out. It's unhappy because it's getting more sunlight and UV light than it's used to. It's a lot warmer up there, and it sort of starts to reach the end of its life. It starts to turn sort of brownish, as you see in this image of the floating mats on the left, and eventually will decompose. So on the right is a photo of a big accumulation of filamentous green algae. You can see some little blobs of living stuff in there, but a lot of that all that brown stuff is just decomposing dead filamentous green algae, and it looks pretty gross, and it smells bad too. It can actually smell a lot like sewage, so it can get pretty stinky. But when it reaches this part of its life cycle, it is definitely towards the end of its life and will eventually dissipate and break down completely. So now I'm going to show you a couple slides with images of benthic cyanobacteria. This is actually benthic cyanobacteria that are floating down a small creek near my house. And for me, this is sort of a weird sign of spring for me. The creek water tends to be pretty clear. So just like I mentioned earlier, they're growing on the bottom, photosynthesizing, putting out a lot of oxygen, and that lifts all of these mats to the surface, and they float down the creek in the spring. Here are some additional images of benthic cyanobacteria. So starting on the lower left, those purple globs floating in that lake surrounded by the green duckweeds, those are benthic cyanobacteria. And the image at the upper left is a close-up through a dissecting scope. And you can actually see some of these filaments that have kind of parted from the mat. this is really kind of interesting. I mean, these are actually true bacteria, but they can get so big that you can see them with the naked eye if you've got really good vision, or even just a magnifying glass. So for bacteria, this is absolutely huge. You wouldn't normally be able to see bacteria in water. And again, the upper right, here's one of those floating bright blue-green mats that we typically see in northern Wisconsin lakes in late summer. And the image on the lower right, that's another mat that's floated up off the bottom. The sort of tan-colored stuff in the mat are lake sediments that got lifted up with the mat as well. But this is another one where you can see all these black hair-like protrusions from the side of the mat are individual filaments that are big enough to see with the naked eye. So that's what a lot of benthic cyanobacteria look like. So when it comes to green lake water, there is a simple test you can do at home to try to figure out if that green water contains planktonic cyanobacteria, so that free-floating type of cyanobacteria. This isn't absolutely foolproof. The only way to absolutely know for sure is to look at it under a microscope, but this is a good, easy test that you can do at home. So basically, you take a jar, you fill it with some green lake water, you shake it up really well, and you just let it sit somewhere undisturbed for about half an hour, or half an hour up to a couple of hours. So most true algae are going to sink to the bottom of that jar. But the planktonic cyanobacteria, because they're buoyant, they're going to float to the surface of the jar and make a scum in that jar, just that you can see through the side of the jar. You're basically mimicking a day with really low wind speed, which will allow the cyanobacteria to float to the surface. And then here are some pictures of the jar test actually out in the field. So starting with that lake image on the right, there's a lot of accumulation close to that shoreline, and I scooped up some of that water, and that made a really thick floating layer in that jar. Here, the image on the left side of the screen, that's more of a lighter scum that you can sort of see forming streaks in here by this boat launch, and a much thinner layer of cyanobacteria floating in that jar. And then this is what it looked like through the side of the jar. This is always interesting for me to look through the side. I can sort of get an idea of what species can be in there. Some of them have really unusual shapes, just weird blobs. Here's some little corkscrew shaped things, some straight filaments too. And of course, there's going to be other aquatic organisms in there that can be really interesting to look at. So that's the jar test. And another reason it's important to look through the jar is you can rule out other things that you might mistake for cyanobacteria, like those tiny aquatic plants. So for duckweeds, so this jar has both duckweeds and watermeal. The duckweeds, you're going to see these roots hanging down from the floating plants, and all of these very regularly oval-shaped leaf green particles up at the top that are about the size of half of a sesame seed. Those are watermeal. So do look through the side of the jar. So when it comes to floating mats, you can get an idea if there's cyanobacteria or something else by doing a stick test. So basically grab a stick, put it under the mat, and lift up. And if it comes up looking like it's covered with paint, probably cyanobacteria. However, if that stick comes up with what looks like long green hair draped over that, that's going to be filamentous green algae, so not really problematic. So sometimes it's short, like this in the center photo in the tweezers. Sometimes there's really huge filamentous green algae, as you see with this rake pole on the right. However, you do have to look at the color, because there's one exception. There is a cyanobacterium called Microcyra that if you did a stick test, you would have it draping over the stick looking like hair, but that hair is going to be black in color. So here you have a contrast between Microcyra on the left side of this petri dish and that leaf green filamentous green algae on the right. So again, this is one of those big filaments of cyanobacteria that you can see with the naked eye. And I'll show you some additional pictures. This is what Microcyra looks like right around the lakes in Madison. I often see it growing what looks like tangled masses of black hair that kind of grows tangled into aquatic plants. And again, This is huge for a bacterium. The filaments can be several inches or several centimeters long. And I'm taking pains to point this out because Microsyra is a potential toxin producer. And unfortunately, we had a dog death earlier this year in northern Wisconsin that was potentially linked to the dog ingesting accidentally one of these globs of Microsyra. So people aren't normally going to want to have something that looks like black hair coming out of the lake anywhere near their mouth. But dogs, unfortunately, aren't going to be too choosy. And unfortunately, this particular population in this lake was producing toxins at that time, and the dog died. So something to watch out for. People are definitely going to want to keep it out of their mouth just instinctively, but keep your dogs away from this too, please. So now I'm going to briefly talk about what it is that makes cyanobacterial blooms grow and accumulate in lakes. And really the simple answer is nutrients. So phosphorus and nitrogen are going to, if there's a lot of the nutrients, phosphorus and nitrogen in a lake, it's going to fertilize the growth of aquatic plants. It's going to fertilize the growth of algae, and it will fertilize the growth of cyanobacteria, sometimes to bloom levels. Tends to be phosphorus that really drives the growth of blooms of cyanobacteria in our lakes, but nitrogen is really important too, especially when it comes to things like some production of some toxins. Some cyanobacteria can make some toxins that require access to a lot of nitrogen. And if there's a lot of nitrogen in the lake water, they could potentially use that to make toxins. Depending on where you are in the state or the particular conditions in a lake, some lakes have issues with what we call internal phosphorus loading from the sediments. That tends to be in lakes that have water at the bottom go anoxic. So there's no oxygen at all in the bottom layer of water in the lake, and that induces some chemical changes that leads to a release of phosphorus from the sediments, and it's a form of phosphorus that's really easily taken up by cyanobacteria and algae and plants. So that can be an issue too. You don't necessarily, even in that case, have to have nutrients coming in from runoff. The lake can just produce its own phosphorus through internal phosphorus loading. And again, depending on where you're in the state, septic systems can be a source of nutrients to lakes too. So septic systems have to be sited in the proper place, so far enough from the lake that you're not making a connection. They need to be the right size for the property, and they need to be maintained properly. And we have seen issues in some lakes in northern Wisconsin where if you've got high water levels and a septic system that's placed too close to the lake, you can actually inadvertently have a hydrological connection through the groundwater between the lake and the septic system, especially when you've got high water conditions in that lake. And there are other chemicals that can run off from land into a lake that give cyanobacteria an advantage over other types of algae. So salt, runoff of road salt and salt that people put on their sidewalks, that can have an effect because cyanobacteria are more resistant to salt than other more desirable types of algae in the lake. So salt can sort of inhibit their competitors and give cyanobacteria a leg up. It's the same case with herbicides. Herbicides were designed to kill plants, and algae, true algae, are the ancestors of plants, so they can really affect the more desirable types of true algae as well. So depending on the herbicide and the concentrations, that can possibly have an effect and basically knock out the algal competition for nutrients in lake water too, and give cyanobacteria an advantage. So that's a good reason to try to minimize your use of salt and herbicides, especially if you live on a lakeshore property. So now I'm going to talk about sort of the physical causes. So wind, or really the lack of wind, that helps to drive cyanobacterial bloom formation, especially planktonic blooms. So planktonic blooms, again, planktonic cyanobacteria float, and we're most likely to see those planktonic blooms forming when you've got periods of low wind speeds or no wind at all. That's when you are most likely to see those scums accumulating at the surface. And especially in summer, we tend to have very low wind speeds or even no wind at all overnight. So I've definitely gotten bloom reports from people who are early birds. They'll grab their cup of coffee and go down and look at the lake first thing in the morning, and they're really alarmed to see a floating cyanobacterial bloom there. And inevitably, they send me pictures, and the lake just looks mirror calm with a scum of cyanobacteria floating. And later on in the day, as the land warms up and as convective winds start to build and that wind speed increases, those blooms get mixed back into the lake water and get dissipated elsewhere. So wind, or really the lack of wind, is very important for scum accumulation. The other thing that's important is wind direction, because you can have, after gentle winds in one direction, you can have floating cyanobacteria all accumulated just from the action of that wind at that downwind shore. So that's also something to pay attention to. If you go out and you look at the lake and there's a big scum floating near the shore, pay attention to what the wind direction is or has been, because that might be the reason you're seeing it there. So again, wind can really drive that localized accumulation of existing cyanobacteria. It doesn't necessarily mean that there's something going on in the lake to increase the growth of cyanobacteria. The wind can just transport it to that downwind shore, and you see that accumulation. So on the left, we've got an image, a satellite image of a couple of lakes in Madison. And I can tell from these images, the wind is coming from the southwest. So it's pushing this cyanobacterial bloom up against this shore. We probably have sort of those pea soup type conditions. If you go on the upwind direction, probably has nice clear water that's perfectly swimmable. So do keep this in mind if you're going out to a lake and you want to swim. If you're at the downwind shore, you might have worse conditions, more likely to see a bloom there. But if you go on to that upwind direction, you might find better swimming conditions there too. And another thing to point out is even in low nutrient lakes, you can have these wind-driven accumulations. I've had bloom reports from folks living on really low nutrient lakes with excellent water quality in northern Wisconsin, and they've reported like a bloom. In that case, it was like a few inches of cyanobacteria accumulating along the lakeshore where they live, and that really concerned them. They thought something had happened, that somehow there was a big nutrient input to the lake to cause this bloom to form. But I walked them backwards through the previous day's weather. They'd had a couple of days with no winds whatsoever, so just all of the very sparse cyanobacteria in the lake then floated to the surface and formed a scum. And then there was a day of gentle wind blowing in one direction towards their lake shore, and basically all the cyanobacteria ended up being driven towards their shore. So important thing to keep in mind if you see blooms where you might not expect them in these low nutrient lakes, it could be one of these wind-driven blooms there too. And biological interactions can be important for blooms as well. So zebra mussels are filter feeders, and there's some research out of Michigan State University about 20 years ago at this point that looked at zebra mussel impacts in inland lakes in Michigan. So zebra mussels are filter feeders, and they filter algae and cyanobacteria out of the water column, but they don't necessarily keep it in their bodies and digest it. They can actually selectively spit out cyanobacteria, and since planktonic cyanobacteria are buoyant, they can just float right back up to the surface and enjoy access to more nutrients because the zebra mussels have taken out their competitors, making it more likely to see blooms in a lake if you've got zebra mussels. Spiny water fleas have more of an indirect effect. So this is a spiny water flea, this sort of weird alien looking thing here. They are predators, and they have an indirect effect because they feed on a lot of the little more desirable types of water fleas like Daphnia that would normally eat cyanobacteria. So if they're they're eating the little guys that would normally eat cyanobacteria. They can sort of inadvertently create conditions that are more conducive to blooms in lakes. And carp can be an issue as well. This image is an aerial photo of Wingra Lake or Lake Wingra rather, in Madison. And this is a big enclosure that was installed in the lake as an experiment. And all the carp were removed from that enclosure. And you can compare how clear that water is. You can actually see the lake plants from this airplane compared to the water containing a bloom all around that enclosure. So carp do a couple of things. They're bottom feeders, and they tend to root around in the sediments that stirs up sediments, and then that can bring nutrients up into the water column where cyanobacteria can take them up. The other thing that they do is they uproot plants, and you really want a healthy aquatic plant community in a lake because they're really going to be your friends in helping to take up nutrients and really compete with the cyanobacteria for those nutrients. Carp basically take the plants out of play, making conditions better for cyanobacteria in lakes. So that was sort of a real quick overview of the chemical and physical and biological impacts that help to lead to blooms. Unfortunately, climate change is an overlying driver, and a lot of the changes that we've already seen in the Great Lakes region since about the early 1950s are leading to conditions that really are more conducive to blooms. So we are getting warmer in the Great Lakes region and in Wisconsin. Cyanobacteria grow better in warm water than other more desirable kinds of algae. So that's one thing that is making things more conducive to cyanobacterial growth. Our growing seasons are extending in both directions. We're getting earlier ice off in our lakes, and quite often we get hit with these really early season hot spells, and so that leads to earlier warming of the water, which gives cyanobacteria sort of a jump start on growth. And we've got later and later ice formation in lakes, so that's really extending the growing season for cyanobacteria into November and December. They like warm water, but they can still grow in cold water. And with a shorter period of ice on the lakes, they're just not dying off over the winter like they used to, unfortunately. Another thing we're seeing a lot of is more precipitation, both as rain and snow in the area, and especially when it comes to rain, a lot more of these really intense rainstorms. So 1, 2, 3 inches in a single rainstorm. That can lead to a lot more runoff, which brings extra nutrients into lakes, which can then fuel blooms. And then in some parts of Wisconsin, we've been seeing some issues with drought as well. And depending on the water body, drought can have impacts as too. It can lead to lower water levels, which essentially concentrates the nutrients already in that lake. And shallower water tends to warm up a lot faster too. So both of these things can help to promote blooms. So I'm going to talk briefly now about some of the health impacts of cyanobacteria. So basically why we are concerned about them. So I'm going to talk first about exposure routes. So cyanobacteria have been around on Earth like 2 to 3 billion years. They've got all sorts of weird biochemical pathways that they've developed over the millennia for coping with life on Earth. They can make a lot of different, what we call bioactive compounds that can affect other organisms. And some of the compounds that they make are classified as toxins. So how people and animals are actually exposed to these toxins are first through ingestion. Are you swallowing cyanobacteria in water? For the most part, most cyanobacterial toxins are held within intact cells as they're growing. There's only one toxin that is normally actually released from growing cells. So if you're swallowing a growing bloom, you are potentially ingesting toxins held within cyanobacterial cells. And then once those cells hit your stomach acid, they break open and those toxins are released. So swimming, immersion activities like that are normally where people are accidentally swallowing water. Inhalation is another pathway. So typically, if you're water skiing or tubing, for example, you're being towed behind a boat. The boat's kicking up spray that sprays you in the face, and you're inhaling some of those water droplets as you're being towed behind a boat. Some people, anecdotally, those with a lot of allergic reactions, can have reactions to cyanobacteria through skin exposure too. It tends to lead to things like skin irritation and rashes, as you see in this photo on the lower right. And it tends to be in places where cyanobacteria are held and rubbed against your skin under clothing. So, for example, this foot belongs to someone who is she was putting a boat, helping to put a boat on a trailer, wading in water that had a cyanobacterial bloom. She had shoes and socks on, and the cyanobacteria got trapped under her socks and then resulted in this kind of nasty looking rash on her ankle. And then just briefly running through some of the toxins that cyanobacteria can make. So these are sort of the major classes of toxins. For those that are listed in red, those are the toxins that we know the most about their occurrence in Wisconsin. So some cyanobacteria can make liver and kidney toxins. Those include microcystins. That's one of those nitrogen-rich compounds that I referred to earlier. So a lot of nitrogen in an aquatic system could lead to microcystin production if other conditions are right. Microcystins are probably the most commonly found toxin in both Wisconsin and globally. Related to microcystins are nodularis, which tend to be more in marine systems, and cylindrospermopsin. That does occur in Wisconsin, not that often, usually in low concentrations. And this is the toxin that I was referring to that's normally released from actively growing cells. Cyanobacteria can make some neurotoxins too. That includes anatoxins and saxitoxins. Those are the most common ones that we find in Wisconsin. These others, guanotoxin, etoxanotoxin, and BMAA, it takes very expensive analytical methods to test for these. So we just really don't have the resources, at least the DNR does not. There's some researchers who might have the capacity to actually run tests for these in Wisconsin. And then I talked about dermatotoxins, those that cause the skin irritation. Those include things like lipopolysaccharides that are in the cell walls of cyanobacteria. So 2 important things about toxins. Not all cyanobacteria make toxins. The vast majority just kind of mind their own business and have not evolved the ability to make toxins. But unfortunately for us, a lot of the main bloom-forming species do have some strains that have the ability to make toxins. But even those that have the ability to make toxins don't make toxins all the time. This is really an active area of research. People are still trying to figure out when and why cyanobacteria make toxins, because they're really energetically expensive molecules for cells to produce. One other thing that's important about cyanotoxins is you can't tell if toxins are present just by looking at a bloom. So just out of precaution, you need to treat exposure to blooms carefully with caution. I'll talk about that in a minute. And when it comes to cyanobacterial bloom exposure, you do need to recognize that exposure risk is going to vary by who you are and what you're doing. So if you are a 2-year-old who's swimming at a lake, you're going to have a very different risk from an adult who's swimming at a lake. So you're a 2-year-old, you have a smaller body, and it doesn't take swallowing as much toxin to make you sick as it would for an adult. Toddlers also, kids in general tend to spend more time in the water and might not be as good at keeping water out of their mouth if they're swimming, and especially in the case of toddlers, just keep putting their hands in the water and then putting their fingers in their mouth. So that's going to be a very different risk from an adult who might actively try to keep from swallowing water if they're swimming. If you're doing things that don't require immersion, like kayaking or canoeing, that's going to be a much lower risk. I mean, I would hope that if you're canoeing, you're never ever going to dump in the lake and accidentally swallow water. So generally, you're staying above water in a canoe, it's going to be a lower risk. But unfortunately, for animals, they're going to have the highest risk um, out of anybody. They have a smaller body size. So again, smaller bodies, it doesn't take ingesting as much to make you sick. And animals can't instinctively judge if water is safe or not. They will actively drink water or eat stuff in lakes that people would just never want to have anywhere near their mouths. So animals unfortunately tend to have worse issues if they're ingesting cyanobacteria. So really one of the good things about cyanobacteria is you can see the blooms that are of highest concern. Anytime you see those surface scums or that opaque pea soup water, that represents really high concentrations of cyanobacteria. And if those blooms are producing toxins, you could possibly be exposed to high toxin concentrations if somehow you were to inadvertently swallow some of that water or water ski or tube across that lake. It's more of a judgment call when you've got things like these floating benthic mats. They're often very noticeable, or they look kind of nasty enough that people wouldn't want to swallow them accidentally. But with animals, it's a different story. They might try to snap at them just as something fun to try to grab out of the water. And I am absolutely no fun at the beach. I've seen the water under the microscope, and I know that water is never 100% safe. There's always other bacteria, viruses, and parasites that could be present that could make you sick. So really, you want to avoid swallowing water as much as possible. So when it comes to personal safety, most of this is just a matter of common sense. You can stay safe and decrease your risk by avoiding swimming and boating in scums and pea soup water. If you're an adult and you can't see your feet in knee-deep water, there's a lot of stuff in that water and you need to find a better place to swim. And it doesn't matter if it's cyanobacteria or something else. Find clearer water. And then when it comes to kids and pets, choose the clearest water possible for them to swim in and avoid swimming in areas that are really shallow, warm, and stagnant because there can be other things in that water that can make them sick other than cyanobacteria if that water is ingested. Shower off after swimming and always avoid swallowing water no matter how clear it looks, especially after a rainstorm. So heavy rainstorms can wash a lot of stuff into lakes, including things like goose poop. And so we often have high bacteria levels at beaches after heavy rainstorms. So really, when in doubt, stay out. And then some points about pets that I really want to emphasize. Unfortunately, a lot of these recommendations come from cases I've helped Department of Health Services investigate in which animals became very ill or even died after ingesting cyanobacteria. So always supervise pets and keep them out of unsafe conditions. Don't just let them run around on their own outside at a lake, especially if that lake has blooms, because they might go down to the lake and ingest scummy water. And again, choose the clearest, cleanest water you can for dogs to swim in, and don't let them swim in shallow, warm, and stagnant water bodies. Always provide a source of clean drinking water for them so they don't have to resort to lake water, and always prevent pets from drinking untreated water. This will help to protect them from parasites like Giardia, waterborne diseases like leptospirosis, and cyanotoxins. After dogs swim, wash them off with clean water so they don't ingest cyanobacteria from their fur. And if you live in a lake that has blooms and you irrigate your lawn, don't irrigate during a bloom because you're basically bringing that bloom up onto your grass. And if your pets eat grass, they're going to be ingesting that bloom and potentially any toxins in it. So this is my contact info. I also get email through the DNR Habs at wisconsin.gov email. I'm interested in knowing where blooms are in the state. So if you see a bloom on a lake, especially a smaller lake where either DNR or local county staff might not have the capacity to do monitoring, please get some photos and send those to me. And let me know about those blooms at dnrhabs@wisconsin.gov. So I think we've got a little bit of time for questions.
Okay. Anyone have those?
I just wanted to know why.
Here, I'm gonna let you speak here so Gina can hear you. Let me turn up the mic. Okay.
You mentioned northern Wisconsin getting more blooms or more frequent blooms, maybe. Why up there? Is it the tannin in the water, or why northern Wisconsin rather than Waukesha County?
Okay, so I couldn't, I think you can hear the microphone better in the room than I can, but I could make out what's going on in northern Wisconsin to cause more blooms. It really depends on the lake. I mean, a lot of people think about, okay, northern Wisconsin, it's going to have really superb water quality, and that is the case for many lakes. But there are many lakes in northern Wisconsin that also just naturally have high nutrient levels, so they're impacted by blooms. We have a lot of impoundments and flowages in northern Wisconsin that were created either in the 1800s to support transporting logs across the state to lumber mills, or they've been created for hydropower projects. And these flowages and impoundments tend to drain really large watersheds, so proportionately they're getting a lot of nutrients. Even though you've got watersheds with really low development, anytime you're draining a very huge area of land relative to that water body, you're getting a lot of nutrients in that way. And just there's a lot of issues with climate change. I got a ton of bloom reports in 2024. I got about 45% more bloom reports than I had in 2023. About 80 to 80, I think 80% of those were cyanobacterial bloom reports. And 2024 was really exceptional. If you think about, think back to the winter of 2023 to 2024, it was an extremely warm winter. We had a very warm December, a warm January. We had the warmest February on record. A lot of lakes throughout the state had really short periods of ice cover. So that was just an example of sort of that extension of the growing season. Things kept growing into December. They didn't die off under the ice, and then they started growing earlier in the spring. And we also had a very wet, I think, May and June. So there was a lot of nutrients coming into the systems too. So it just kind of set things up for more growth of blooms.
Hi, Gina. So I live in Lac-La-Belle, and I'm wondering, is there somebody in public service who we could call or take a sample to if we're worried about, like, let's say I do the jar test and I want to know, is it safe enough for a party? Is there somebody locally I can ask that question to?
Well, there's a couple of things that you can do to try to confirm blooms. You can do the jar test. You can certainly send me photos of the lake, and I can confirm whether you're seeing a bloom or not. But really, the testing is tricky because there are a lot of labs that can analyze for cyanotoxins if that's what you were interested in analyzing. Wisconsin State Laboratory of Hygiene can do it. But there is usually a large gap in time between when you actually grab that sample and when the lab can provide you with results, and conditions can change in that time. So I would just say in general, if you see a lot of cyanobacteria at your lakeshore and people are expecting to swim, they really shouldn't be swimming in that. If you have the capacity to maybe go out and swim further out in the lake when they're off of a boat, if there's a lot less cyanobacteria out there, that would be safer. I'm sorry, I don't have a good answer for that. I mean, I know there's one test kit that's available on Amazon that is pretty inexpensive. You can buy it at home, and I've actually used it. The processing for it's a little bit weird. I don't like the marketing for it because they advertise it as saying if there's cyanobacteria present or not, and that's not true. It only tests for one type of toxin, and it won't tell you if the other toxins are present. So it's sort of a false sense of security if you decide to use this. Just in general, if you've got a lot of cyanobacteria present, I would, depending on what you're going to be doing, try to stay out of that water or pick some other activity to do around the water.
Gina, can we, if you stop sharing your screen, then we can see you.
Oh, sure.
Yeah.
There we go.
Okay.
Hi, Gina. Yes, I'm wondering, so after the bloom, the algae bloom seems to dissipate, where is it going? Is it falling to the bottom, or does current take it away, or can you explain that, please?
Yeah, so where does the algae bloom go and it dissipates? Well, it depends on what's going on. Let's say you've got one of those early morning blooms during really calm conditions, and then the wind picks up. It's going to be blown whatever way the wind goes. If the wind is really strong and there's waves, it's going to be mixed back into the water column. If you have a bloom that's decomposing, for the most part, those cells just break down and die. However, there are some types of cyanobacteria that can make resting cells that sort of act as seed stock for future blooms. So those resting cells tend to drop down into the sediments, and they just kind of wait out for better conditions when they might start to sprout and grow again. So usually resting cells are sort of formed at the end of the life cycle of a species or towards the end of the growing season, and they just get deposited in lake sediments.
Okay, thank you.
You've covered it a little bit, but about swimming, a lot of times we'll have algae blooms for the first 5-6 feet right on the shore. We go out on our dock and be maybe 50 feet away, 20 feet away or more. Is that okay? I mean, it seems like there's a definite line on the bloom. I'm always wondering if it just is concentrated, but it isn't quite pea soup or, paint yet.
So were you talking about trying to find conditions for swimming? I didn't quite hear you clearly at the beginning of your question.
And so you've got a bloom on your shore,
Okay.
want to swim, and so you go out on your dock 30 feet, 40 feet from the shore, it looks clear. Are you okay, or how many feet do you need to be separated from the bloom and swimming?
Okay. I can't give you specifics on the exact distance you need to be from the bloom, because obviously that's going to be very different depending on conditions. Just in general, the clearest water you can have is going to be safer. And it also might depend on how you're swimming. If you're like me and you're dog paddling with your head out of the water, that's going to be safer than if you're doing the full-on crawl and potentially ingesting water that way when your head's under the water. But in general, clear water is going to be safer for swimming, especially if you're going to have your head underwater or your face in the water.
I can ask a second question, and that is, a lot of times there's not a bloom that you can see, but when you're looking at water, you see lines in it, like a little web. And I'm thinking, is that the start of a bloom? And we should be careful, or that could be that as something else as well.
Are you talking about sort of the foam lines that you see on windy days?
No, I'm saying
Oh.
in the water itself, you can just see greenish stuff. And it looks like little lines, that'd be like a eighth of an inch, we might be a foot or two. It's 6-10 feet long, but you see these little.
All right. Well, if you're talking about green lines that are formed by like tiny particles that are floating on the surface, that might be cyanobacteria. But if you're talking about something that's more hair-like under the water, that's probably filamentous green algae.
Okay.
Hi, Gina, thank you. Two questions. One is about, is it specifically chloride that's the problem? Because more of the lakes are checking our chloride levels more frequently in different parts of the lake. And then the second question is, aerators are controversial on our lake in any season, but is there any role for aerators? If I live on a hot, windless, shallow bay, is there anything I'm gonna achieve with an aerator in terms of cyanobacteria?
Okay, so first, yeah, it is the chloride that tends to have the impact on aquatic organisms. For aerators, I don't know all of our regulations around them in lakes. I mean, we most commonly use them in winter, just to when we've got lakes that have issues with going anoxic with fish kills, to keep an opening in the ice in the winter. I don't know as much about what is allowed for the use in the summer, and it may depend very heavily on the water body. At the very minimum, there's permitting required because it could potentially be a navigational hazard in the lake. Yeah, I'm sorry, I just don't know enough to tell you what would be allowed for aerators.
You know, I've been taking notes as I can, but I'm wondering if the slides that you presented for us are available for those of us that got tickets. Can we get an email copy of them?
Yeah, I can certainly send over a PDF copy of the slides, and if you can, Paula, if you can send them out to the registered folks, I'm fine with that.
Okay, happy to do that. Yeah. Okay. Okay, well, Gina, thank you so much for joining us tonight. We really appreciate you coming on, and this is our first experience with the hybrid model, so we appreciate you working
Okay.
with us on this.